Okay, for today's lesson, we're going to do something similar, but a little bit different than we've been doing the last 3 days. So today we're going to work on drawing and labeling rectangles with the same perimeter, but now they're going to have different areas. Okay, and before we jump into our lesson, we're going to quickly review distributive property and writing those equations. So for our rectangle here, I divided it into two littler rectangles and I color coded them to hopefully help us out. So when we're thinking about this one, for our first equation, we're going to think, well, it is 3 high, so we know it's going to be 3, and then we're going to add these two numbers together. So 4 plus 6 is 10, so we're going to put that in there, and then we're just going to find area normal. So 3 times 10 is 30. For our next one, we break it apart a little bit. So we're going to keep our same 3 because it's 3 high. And this time we're going to keep these separate, 4 and 6. And again, when you go to solve it, we have 3 times 4 plus 6. We have to do 4 plus 6 first. So then it looks like the top one, and it equals 30. And then for the last equation for distributive property, we're going to break it apart as if it was two rectangles. So we're thinking this one is 3 by 4. And this rectangle right here, it's still 3 high. So we know it's 3 by 6. So then we just plug those numbers in to our equation over here. And we have 3 times 4 is 12. And we have 3 times 6 is 18, and we know when we add those together, we get 30. With distributive property, even though we wrote the equation 3 different ways, our answer was always the same. If you end up with a different answer, then for one of them, there was a mistake made, and you need to go back and look at it. Okay, quick review. We just need to remember area is length times width. It's the measurement of the inside of a figure, and perimeter is all the side lengths added together, and it's the measurement of the outside of a figure. So now we're going to get into drawing rectangles and labeling them that have the same perimeter, but they have different areas. So we're going to follow a certain set of steps. First, we're going to write down our given perimeter. Then we're going to divide that given perimeter by 2. We're going to cut it in half. Then we're going to write down different addition equations that equal the answer when we divided the perimeter in half. So we have to know our math facts, and we cannot use 0 in our equations because it won't work to draw a rectangle. Then we're going to draw rectangles with the different dimensions using the add-ins from our equations. And then we're going to figure out the area of each rectangle. So for our first example, the given perimeter we're going to use is 10 units. For our second step, we're going to divide that perimeter in half. We're going to cut it in half. So we're going to divide it by 2, which is 5. So we're looking at this number right here when we go on to step number 3. We're going to now write down different addition equations that equal the answer of 5. So we have 1 plus 4 is 5, and 2 plus 3 is 5. Again, we cannot use 0 because we can't draw a rectangle with 0 as one of the sides. Our next step, we're going to draw rectangles with those dimensions. So we have a 1 by 4, and we have a 2 by 3. And then our final step is to determine the area of each rectangle. So we have 1 and 4. So we know 1 times 4 is 4, and it's units squared. And down here we have a 2 by 3, and we know area is length times width. So 2 times 3 is 6 units squared. For our second example, we're going to write down the given perimeter, and this time we're going to use 12. Our second step is to divide that given perimeter by 2. We're going to cut it in half. So we have 12 divided by 2 is 6. So now we're going to write our different addition equations that equal 6 that we got when we divided our perimeter in half. And we end up with 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6. Now we have to draw those rectangles with those different dimensions. So our first one, taking those add-ins, we have a 1 by 5, then we have a 2 by 4, and then we have a 3 by 3. And then we have to determine the area of each rectangle. So we have a 1 by 5, and we know area, length times width. So 1 times 5 is 5 units squared. Then we have a 2 by 4. 2 times 4 is 8 units squared. And then we have our third one, which is a 3 by 3. 3 times 3 is 9 units squared. For example number 3, we're going to make our number a little bit bigger. So for this one, our first step is to write down our perimeter, and I'm going to give it's 30 units. So our next step is we have to divide that perimeter by 2. So we have to think, what's half of 30? 30 divided by 2 is 15. Now our third step is to write down all those different addition equations that equal 15. So this one's going to have a few more than it did when it was just 5 or 6. So we have 1 plus 14 is 15, 2 plus 13 is 15, 3 plus 12 is 15, 4 plus 11 is 15, 5 plus 10 is 15, 6 plus 9 is 15, and 7 plus 8 is 15. Okay, all of those add up to half of our perimeter, so halfway around it needs to be 15. Then we have to draw those rectangles. So we end up with a lot more rectangles the bigger our perimeter gets. So we have a 1 by 14, 2 by 13, a 3 by 12, a 4 by 11, a 5 by 10, a 6 by 9, and a 7 by 8. And then our last step is we have to find the area of each one. So our 1 by 14, 1 times 14 is 14, so we have 14 units squared. Then we have 2 by 13. 2 times 13, or 2 groups of 13, is 26 units squared. Then we have a 3 by 12. 3 times 12 is 36 units squared. Then we have a 4 by 11. 4 times 11 is 44 units squared. We have 5 by 10. 5 times 10 is 50 units squared. We have a 6 by 9. 6 times 9 is 54 units squared. And we have a 7 by 8. And we know 7 times 8 is 56 units squared. So we always have to figure out the area of each rectangle that we draw. Now we are going to compare the answers we got for our first and second examples. So we're going to look at when we had 10 units, we had 2 rectangles, and when we had 12 units for our perimeter, we had 3 rectangles. So we had a 1 by 4, which was 4 units squared, and we had a 2 by 3, which was 6 units squared. And then on the side with 12 units, we had a 1 by 5, which was 5 units squared, and we had a 2 by 4, which was 8 units squared, and we had a 3 by 3, which was 9 units squared. So we're going to look at those and see, what dimensions give the smallest and largest areas? So looking at the one on the left for 10 units, the smallest area was our rectangle that was 1 by 4. It was the one where the dimensions were farthest apart. And if we look at the one on the right for 12 units, it was also the smallest area, the ones that were farthest apart at a 1 by 5. So to find the smallest area when working with a certain perimeter, we need to use the figure where the side length measurements are farthest apart. So then on the flip side, for the largest area, we need to use the ones that are closest together. So on the left, where it was 10 units, it was 2 by 3. 2 and 3 are right next to each other. Those are closest together. Plus, we only had 2 options on the left. On the right, for 12 units, it's going to be our 3 by 3. Those are the closest together. They're the same number. Okay, so for our largest area when working with a certain perimeter, we're going to use the figure where the side length measurements are the closest together. For our last example of the day, we're going to draw rectangles that have the smallest and largest area when the perimeter of each is 18 units. So we're going to go through our steps again. We're going to write down our area or our perimeter, which is 18 units. Then we're going to divide that perimeter in half. We're going to divide it by 2. So 18 divided by 2 is 9. So we're going to use this 9 as we move on to our next step of writing down different addition equations that equal the answer that we determined in the previous step, which was 9. So we have 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, and 4 plus 5 is 9. Now we're going to think about what add-ins do we need to use that will create rectangles that have the largest and smallest areas. So we're not going to draw all 4. We're going to think about which 2 should we use. Which one's going to give us the smallest area and which one's going to give us the biggest area. So remember, the smallest area is made by dimensions that are the farthest apart. So if we look, 1 and 8 are farther apart. They're 7 apart. 2 and 7 are only 5 apart. 3 and 6 are 3 apart. And 4 and 5 are right next door. They're 1 apart. For the largest area, it's made by dimensions that are closest together. So thinking back to what we just went over, 4 and 5 are 1 apart. That was the closest together that we could get. So we're going to say 1 by 8 is the smallest, and we're going to check our work. And 4 by 5 is going to give us our largest area. So we're going to draw those rectangles, a 1 by 8 and a 4 by 5. And we have to determine the area of each. So we have 1 by 8. We know 1 times 8 is 8. So we have 8 units squared. And this one is a 4 by 5. 4 times 5 is 20 units squared. So right now it looks like we're pretty good. 1 by 8 is smallest out of these two, and a 4 by 5 is the largest. Now just to make sure, let's look at these right here. So if I drew a rectangle that is 2 by 7, we have 2 times 7, so my area is going to be 14 units squared. And then we have a 3 by 6, and 3 times 6 is 18 units squared. So we just double checked and made sure, yes, we're truly right. This one is the smallest and this one is the biggest. We will continue to work on this concept tomorrow. Have a great rest of your Monday.